This is question 15 from the second CSAT sample paper. In this question we've got a bag of 3 black balls and 3 white balls, and there's a game I play. I draw 3 balls and I win if I get all 3 balls the same, but if I don't, then I have to have 2 black and 1 white, or 1 black and 2 white. It has to be a pair 2 and 1. So I put back the 2 that were of the same colour, and then I just reject the one that's of a different colour. So then there's only 5 balls left. And I keep repeating this process, and I lose the game if there's only 2 balls left in the bag, but I win as soon as I get 3 balls that are the same colour. And we ask for what is the probability that I win the game. So if you want to have a go at this question yourself, pause the video now. Okay, so it looks like this is going to be a probability tree question, because there's a bunch of options at each stage and each one has some probability, and I'm just seeing which ones end up with me winning. But there's a few steps to this process, so we'll just do a probability tree for each step at a time, because otherwise it will get very messy. So let's think about the first step, where there's 3 black balls and 3 white balls, so I haven't thrown away any balls yet. So I've drawn this tree. My starting state is 3 black balls and 3 white balls, and there are 4 possibilities. I can get 3 black, 2 black and 1 white, 1 black and 2 white, or 3 white. At the moment I'm not worried about the order, although I will have to worry about the order when I calculate probabilities. So in either of these edge cases I just win straight away because I've got 3 the same. And then if I get 2 blacks and 1 white, what happens is I throw away the white ball and I keep the 2 black ones. So then I have 3 black balls and 2 white balls. And in this case I'd have 2 black balls and 3 white balls. So now we'll have to think about what happens in each of these cases. So if I start with 3 black and 2 white, what can happen? Because these are completely symmetric, it's enough just to think about what happens in this case. So I'll just deal with there being 3 black and 2 white, because if I drew this it would be exactly the same, just with white swapped for black. So I'll just draw this one next. So now I start off with 3 black balls and 2 white balls, and now getting 3 white balls isn't a possibility because there's only 2 there. So there are 3 possibilities. I can get 3 black, 2 black and 1 white, or 1 black and 2 white. So if I get 3 black I win. If I get 2 black and 1 white, then I throw away the white, keep the 2 black, so I've got 3 black and 1 white, and we'll see in a second what happens in that case. If I get 1 black and 2 white, then I throw away the black ball, and I have 2 black and 2 white. But that's a problem, because now, whenever I try to play, I can't possibly get 3 the same, because there's only 2 of each colour. So whatever happens, I'm eventually going to lose. I'll just throw away 1 ball each time, and then I'll get down to only 2 balls left, and that's the condition for losing. So whatever happens here, I definitely lose. So now let's think about the case where I start with 3 black balls and 1 white ball. Okay, so in this case, I can't draw 3 white, but I also can't draw 1 black and 2 white, because there's only 1 white left. So I can either draw 3 black or 2 black and 1 white. If I draw 3 black, I win. If I draw 2 black and 1 white, then I throw away the white ball and I just have 3 blacks left. And that means the next time I draw, I'm guaranteed to win, because I just pick 3 black balls out of 3 black balls and I win. So whatever happens, as soon as I get to this case, I win. And that means I can go back to this picture and modify it. So we can say whatever happens in this case, I win. So basically, once I get to this case, either I win or I lose. But there aren't any more cases to analyse once we get to here. Bear in mind, again, I could do exactly the same, but with 2 black and 3 white, and it would look exactly the same, just with all the blacks and whites swapped around. So now we have to start calculating probabilities. I think it's easiest to first calculate the probability of winning from this case, and then go back to the start where I had 3 of each and calculate the probability of winning from there. So first we'll start with this case and find the probability of winning. Okay, so let's try and calculate the probability that I win, given I've got to this state with 3 black balls and 2 white balls. And because there's two cases where I win but only one where I lose, I think it's easier to do 1 minus the case where I lose. So I'm doing 1 minus the probability of getting a black ball and then 2 white balls. Or some other order, so white, black, white, or white, white, black. So if I ignore the order for a second, what's the probability of this happening? I've got a 3 in 5 chance of getting black, then 2 in 4 of white, and then 1 in 3 of white. So there's 3 black left at the start, and then 2 white, and then 1 white. But I need to worry about the order. So to change the order, I could just work out white, black, white, and then white, white, black separately. But you can see what happens each time is I'm moving these numbers on the top around, but it's the same 3 numbers each time. So sooner or later, I'm going to have to draw 1 out of 2 white balls, and then the other one. So that's a 2 and a 1 on top. And I'm going to have to draw 1 out of the 3 black balls. That's going to be a 3 on top. So for instance, if I had white, black, white, it would be 2 over 5, and then 3 over 4, and then 1 over 3, but the numbers on the top are still the same. The numbers on the bottom are still the same, it's just the numbers on the top change order. So because there's 3 different orders this can go in, actually all I have to do is multiply this by 3, and that gives me the answer. So what does this come to? Well, this 3 cancels with the thirds, this is just a half, so I've got 1 minus 3/10, and that just comes to 7/10. So the probability of winning, given I've got to this point, is 7/10. So now let's go back to the initial state and work out the probability of winning from there. Okay, so here's my probability tree, and I want to work out the probability of winning, given this position. So remember, once I get to here, the probability of winning is 7/10. So how do I win? Well, I either get 3 blacks or 3 whites, or I have 7/10 times the probability of getting one of these two. And the probability of getting 3 blacks or 3 whites is the same, and the probability of getting these two is the same. So I've got probability of 3 blacks plus probability of 3 whites, plus 7/10 probability of this, 7/10 probability of this. So getting 3 blacks, what's the probability of that? I have 3 out of 6 first, then 2 out of 5, then 1 out of 4. So I've written that, but I've multiplied by 2 because these two probabilities are the same, so I'm just doubling that. And then, how do I get black, black, white? It's 3 out of 6 times 2 out of 5 times 3 out of 4, because there's then 3 whites out of 4 balls total at the end. But as before, I have to multiply by 3 because there's 3 possible orders I can put it in. The numbers don't change when I change the order, but I need to multiply by 3 because there's 3 orders. And I've multiplied by 7/5 because it's 7/10, and then I'm multiplying by 2 because there's 2 of these. So now we just have to simplify this expression. So it's worth noting this here is a half, so this becomes 1/5, this becomes 3/20, this becomes 9/20 times 7/5. This one here becomes a half times 1/5, sorry, times 2/5 is 1/5, and I get 1/20, and I multiply by 2. So the first one comes to 2/20, which is 1/10. This part comes to 9/20, and I multiply by 7/5. So what's this going to be? It's going to be 63 hundredths, and I can call this 10 hundredths. So if I add those together, it comes out to 73 hundredths, and that's my final answer.